This video is about significant figures, how to recognize and identify them, and how to add, subtract, multiply, and divide, being cognizant of significant figures. So significant figures, anytime you have a number from 1 to 9, any whole number, any digit is always significant. So that is always important, any non-zero numbers. Now, captive zeros are always significant. What that means is if I have a non-zero number, let's say 1, 0, 9. Let's say I had 109. This 0 is captive between the 1 and the 9. The 1 and the 9 are significant always. Any number between 1 and 9 are always significant, and any zeros that are captive, or sometimes I say they're sandwiched zeros. So the number 109 would have 3 sig figs. Also, any trailing zeros are always significant when they are to the right of the decimal place, and trailing zeros whenever they're in scientific notation. So when I say to the right of the decimal place, if I said 3.0, that 0 is to the right of the decimal place, therefore it is significant. This would have 2 sig figs. Because remember, this non-zero number is always significant, so this would have 2. Or if I said 3.320, again, the 3, and the 2 are always significant, and the 0 is trailing and to the right of a decimal, so this would have 4 sig figs. Now, always not significant are leading zeros. For example, this 2 is significant. It is a non-zero digit. However, these numbers before it are called leading zeros. They are not significant. So this would only have 1 sig fig. Trailing zeros that are not significant are when they are to the left of a decimal place. For example, 1,000. So the decimal would be at the end of that third zero. So these 3 zeros are trailing my 1 significant figure. These are trailing. They are not significant. This also would have 1 sig fig. So this is just a little diagram kind of showing you this number, 3090. This 0 is captive or sandwiched between the 3 and the 9. So the 3 and the 9, of course, are significant. That 0 in between them is captive. It is significant. The 0 at the end, though, is a trailing, not significant number. So this would have 3 sig figs. In this number over here to the right, we can see that these 3 zeros are leading zeros, not significant. Of course, the 8 and the 2 always would be. The 0 in between them is sandwiched, so or captive, it is significant. And this trailing 0 is to the right of the decimal, it is significant. So this would have 4 sig figs. Now, what if I said we needed to round to get to 3 significant figures? So if your calculator gives you an answer of 0.028675, and I only needed 3 significant figures. Well, we know that these leading zeros do not count towards being significant figures. So I would say, well, this is number 1, this is number 2, this is the third sig fig. So I would draw a line after my third, and then we just use regular rounding rules. What does that 7 normally do to a 6? Does it round it up, or would it stay the same? And because it's above 5, it would round it up. So I would round up to 0.0287. Again, I would count significant figures. So that's 1, that's 2, that's 3. This 3 is not going to bump that 3 up. So it's going to remain at 18.3 for 3 sig figs. 3 sig figs here, I would count 1, 2, 3. I would draw a line there. That 5 would round that 7 up. So I would make this number 6.88. And lastly, 92.85, I would say 1, 2, 3. I would draw my line. That 5 is going to make that 8 a 9. So all of these now have 3 significant figures. Now, depending on the device that we are using to measure, or in this case, record the stopwatch, which is recording time, dictates how many significant figures we have. So if I was using stopwatch A, and we said in market, set, go, and then we stopped, and it read 35 seconds, this would be, I would have 2 significant figures in that recording. Stopwatch B said, well, no, it's actually 35.1. So not only are we being more precise, but we now have 3 significant figures in this measurement. And stopwatch C said 35.08 seconds. So that now has 4 significant figures. Now, if a number is less than 1, the placeholder 0 is never significant. Why is that? That goes with that rule that all leading zeros are not significant. So all of these numbers, 0.5, 0.05, 0.005, all have 1 significant figure. Now, if a number is greater than 1, like 50, 500, 5,000, these are now trailing zeros and to the left of a decimal. Also, those are not significant. So they all have 1 significant figure. So hopefully some of those examples helped. I want you to pause the video and go through these examples and try to figure out how many significant digits or sig figs are in the following measurements. So pause and then come back to check. Okay. Hopefully you looked at letter A and saw that every one of those numbers was a non-zero digit, so therefore there are 5 sig figs. In letter B, this is a leading zero, not significant, so 3 sig figs. A leading 0, so 1 sig fig. This 0, so the 1 and the 2 are significant. This 0 is sandwiched, so it is. Yes, this is a trailing 0, but it's to the right of a decimal, so it is significant for 4 sig figs. Here, the 2 and the 5, of course, are, and these 2 zeros are sandwiched, so all of them are significant for 4. The 2 and the 5, of course, are. These zeros, yes, they're trailing, but they are to the right of the decimal, so they are all significant. Same kind of example, that 0 is to the right of the decimal, so 3 sig figs. And here we only have 2 because that leading 0 is not significant. All right, one more practice here. Pause the video here and attempt to figure out how many sig figs for these. Okay, did you have 2 for A? Again, these leading zeros would not be significant, so there would just be 2. For B, that leading 0 is not, that trailing 0 is because it's to the right of the decimal. So 4 here, 2 here, that's trailing 0 to the left of the decimal, doesn't count. Trailing zeros would not count, so just 2 there as well. Only these 2 zeros would count. These are leading zeros. Only those 2 numbers would count. These are leading zeros. All of those would count, and only 1 would count for H. So, rounding. Similar to what we did in the slide a few slides ago, if the digit is less than 5, we drop all non-significant digits. If the first non-significant digit is greater than or equal to 5, we increase. So, if this is what my calculator displays, and I know I only need 3 sig figs, I am going to go 1, 2, 3. Will that 3 do anything to my 7? No, it's going to be left at 15.7. If my calculator displays 18.7, 7500019, that 5 is going to round that up to 18.8. What I want you to look at here is if I had a measurement, 183 milliliters, and I only needed 2 sig figs. I would say 1, 2, draw a line here. That 3 is not going to round that 8 up. So it's easy for people to just say, oh, 18. Well, I can't take 183 and say that that is equivalent to about 18. I need to put a 0 in for that placeholder. That's what that was saying. You can't have, like we said, if we only kept 2 digits, 18 milliliters is only about 10% of that 183 milliliters. So you need to add that 0 as a placeholder. And remember, that's okay to do that because this is a trailing 0 to the left of the decimal. That is not a significant digit. Round this 48,457 to 2 sig figs. So again, I would say 1, 2. That 4 is not going to round that 8 up. So I'm just going to write 48,000. So for all those, I'm just going to put zeros as placeholders. So 48,000 grams. So try rounding these to 3 significant figures. Pause and come back to check your answers. All right. Check your answers and pause the video to see if you have any questions. Now, what do we do if we are adding or subtracting numbers? When we add or subtract, we need to round the result to the same number of decimal places as the least number of decimal spots, or the least precise value. What that means, and I'm going to give you some examples on the next slide. If I said 14.27341 plus 2.1. So I'm going to bring down my 1, my 4, my 3, my 7. That would be 3, 6. So it'd be 16.37341. But my least precise value, or my least number of decimal points, was to my 10th position. So my answer can only be to the 10th. So I would say, okay, well, my 7 would round that 3 up. This would be 16.4. Same with subtraction. Now, when we multiply or divide numbers, we need to look at each of the numbers that we're multiplying or dividing and see how many sig figs they have. And my answer will be the same as the least number of significant figures. What that would mean, for example, if I said 5.2 times 7.123. My final answer, I would need to go, okay, well, this has 2 sig figs, and this has 4 sig figs. My least of those 2 is 2. So my final answer can only have 2 sig figs. Here's another example. Let's say I have these 3 masses and I'm adding them together. So I bring down my 1. I have 8 plus 5 is 13. Add these all up. You get the idea. 115.631. But again, this first measurement is to the tenths, and it is the least precise. Therefore, my answer can only be to the tenths. So I would say, okay, well, is that 3 going to do anything to the 6? Nope, 115.6 grams. So try adding and subtracting these 4 examples. Pause the video and come back to check in a minute. Check your answers. For A, notice we can tell that of these 3, this is my least precise to the tenths. This is to the hundredths, and this one's to the thousandths. So my answer needs to be to the tenths. And same for B, C, and D. Now when we're multiplying or dividing, again, we're limited by the value with the fewest sig figs. So I would look at this number and say this is 3 sig figs and this one has 2 sig figs. So my final answer can only have 2. I'm limited by my 2. So I would say 1, 2. Is that 4 going to do anything to the 3? Nope. So my final answer would just be 33 centimeters squared. So try using your calculators and pause the video to round off your answer to the correct number of significant figures. Check your answers here. Again, I was limited by 2 sig figs, so I had to round this to 610 to get my 2 sig figs. Here I'm limited by 3. Here I was limited by 2. And here I was limited by 3. Now, something to be careful of is your calculator and being cognizant that your calculator is a tool and we need to know how to use our tools. So let's say, for example, I typed in 4.2500 plus 1.75. If you were to try this in your calculator right now, your calculator will probably tell you just like this one did, and it'll just say 6. However, we need to be aware that this 1.75 is my least precise measurement of the 2, and I need to have an answer to my hundredths position. So you would need to record your answer as not just 6, but 6.00 whatever, centimeters or whatever we are measuring. It is important, even though your calculator might tell you 6, that you need to still look at, well, what am I trying to be precise to? What are my measurements giving me? So that's an addition example. Here's a multiplication example where this calculator, they typed in 36 times 73 and they got 2,628. But if I look at my 2 numbers here, I have 2 sig figs here and 2 sig figs there. So my final answer, 2628, that can only have 2 sig figs, I would say, well, that 2 is not going to make that 6 a 7. So 2600, 2,600, and then whatever your unit is, would be my correct answer for this. So hopefully that helped you with significant figures and how to round correctly.